In this chapter, we will look at radical expressions and functions. Radical expressions and functions are those that contain roots. And by roots, we're looking at this symbol or a similar symbol with a smaller number in it. These are called roots or radicals. Square root functions are used to describe a phenomenon that is continuing to grow, but whose growth is slowing down. For square roots, we've talked before that if we have 5 squared, we'll get 25, or negative 5 squared will give us 25. So the inverse operation of squaring a number is to find the square root of a number. For example, a square root of 25 is 5 because 5 squared is 25. A square root of 25 is also negative 5 because negative 5 squared would give me 25. In general, a root looks for identical factors multiplied together. So if we have the nth root of a, the nth root of a equals b, means that b to the power n equals a. An example, the cube root of 64 is 4 because 4 to the third power is 64. These are inverse operations, raising a number to a power and taking the root of that number. Unfortunately, we have 2 different scenarios with roots. And it all depends on if that number inside the radical symbol is even or odd. If n is even, we have 2 square roots. The square root of 4 is 2, since 2 squared is 4, and negative 2, since negative 2 squared is 4. We call the positive 2 the principal or positive root, and the negative 2 is the negative root. Only even radicals have this situation, where they have a positive root and a negative root. If we are just given the radical symbol with a number under it, this is representing that principal root, so the square root of 4 would be 2 in this notation. If we wanted the negative root, we would put the negative in front to get the negative root. Just a small note on notation when it comes to these radical symbols. Also, for even roots, if I look at the number underneath the radical, that number has to be greater than or equal to 0. If I have a negative number under that even radical, I do not have a real number. That also means my domain for an even radical is 0 to infinity. We're not allowed to take an even root of a negative number. We talked a little bit about this in the functions chapter when we were talking about domains. We cannot take a square root of a negative number, so for square roots, we had to look at the domain in a different way. Underneath the radical, how do I ensure that whatever that is greater than or equal to 0? So even roots have some restrictions to them. But let's take a look at odd roots. If n is odd, there's exactly 1 root, and my domain is all real numbers. So for odd roots, we have no restrictions. The cube root of negative 8 is negative 2, because negative 2 times negative 2 is 4, and 4 times negative 2 is negative 8. So negative 2 would be the cube root of negative 8. Now what I want you to do is pause the video at this point and try the problems on this page of your notes. Evaluate each expression by finding the principal root of each expression, or state that the expression is not a real number. So in this page, we're practicing some of the operations that you've done before, but it may have been a while. And that's okay. I'm going to leave the first row to you, and let's talk through the second row. So we'll do number 2 together right now, and then I'll have you pause, try them on your own, and then when you resume, we'll talk through them. So for number 2, I have the square root of 1 over 25. And it turns out that I can consider this 1 is 1 times 1, and 25 is 5 times 5. So I can also rewrite this as 1/5 times 1/5, or 1/5 squared. The square root of 1/5 squared, these 2 operations cancel each other out. and we're left with 1/5. Notice that when I took that square root, when I made that simplification, I used up the square root symbol. It's gone now from my answer. It's just like if we take 3 and square it, we end up with 9. We don't put that 2 again. We leave the 2 exponent off because we've used it up when we squared the 3. The same thing happens here with a square root. When we take the square root, we don't need that square root symbol anymore. Part B might be a little bit trickier because it is decimal numbers. We could check our answer using our calculators, but let's try to reason it out first. 4 is 2 times 2, so maybe 0.04 would be 0.2 times 0.2. And sure enough, if I square 0.2, I get 0.04. So then that's going to leave me with 0.2 or 2/10. How about for part C? Negative square root 0.64. Well, my answer should be negative because of this negative. 64 is 8 times 8. So 0.64 will be 0.8 times 0.8, or 0.8 squared. And the square and the square root cancel each other out, and we're left with negative 0.8. So pause the video, try the rest of them out, and when you resume, I'll have the answers. Taking a look at number 1, did you get 6 for part A, negative 6 for part B, and not a real number for part C? The square root of 36 is 6. The negative square root of 36 is negative 6. But the square root of negative 36 is not real because the number underneath the radical is negative. And this is an even root. Looking at number 3, we would simplify the inside underneath the radical first. 25 minus 16. 25 minus 16 is 9. Take the square root, we'll get 3. In part B, we're taking the roots first. Square root 25 minus square root 16. So square root of 25 is 5. Square root of 16 is 4. 5 minus 4 will give us 1. So our answer for B is 1. And for C, 16 minus 25 under the square root. In this one, just like before, we would simplify under the radical first. 16 minus 25 will give us a negative 9. Square root of negative 9, the square root of a negative number, is not real. So we would write that. Cube root of 27 is 3 because 3 cubed will give me 27. Cube root of negative 27 is negative 3 because negative 3 cubed will give me negative 27. And this one, the opposite root of 27, the root of 27 is 3, but opposite that is negative 3. For number 5, we can look at it similarly to how we did 1 over 25. 125 is 5 times 5 times 5, so we can look at this as the cube root of 1/5 to the third power, which will give me 1/5. Similarly for B, 1000 is 10 times 10 times 10, so the cube root of 1/10 cubed is 1/10. And then last on this page, looking at powers of -1. So the sixth root of -1, because this root is even, there are no real answers. When we have a negative underneath that radical, we have no real numbers. But check out B and C. What do you notice about these numbers? Now, these values right here are called indices, or for singular, index. The index of the radical. An odd radical can have negatives underneath, and sure enough, a 9th root of -1 is just -1, and a 101st root of -1 is -1. The only way to multiply and get -1 when we're talking about the same number is if we multiply -1 times itself an odd number of times.